Let's start with part 3 of the demo. Our delivery drone has been successfully onboarded to the Edge Manager and it's operational. However, it is currently missing a critical application. While we could edit this device individually and add the application directly, we have already pre-created a drone fleet that defines the desired state configuration, including the application for any device that joins the fleet. Rather than managing the devices one at a time, we'll use the fleet model to apply configuration consistently and at scale. If you recall, the devices become associated with the fleet by applying the device labels that match the fleet's device selector. What we need to do is add a label to our device so it will join the fleet. And you can see the moment I added the label that the device joins the fleet instantly. The agent on the drone device has checked in. Because the device's current configuration does not match the desired state defined by the fleet specification, Edge Manager automatically instructs the device to reconcile itself. This reconciliation is initiated by the device agent and occurs without manual intervention. Note that the device update status changes from out of date to updating, indicating that the device is pulling and applying the drone cam application defined by the fleet. The drone cam application has been successfully provisioned and it's in the running state. The update message of the day configuration source is present and being tracked, indicating that the system configuration content defined by the fleet is actively managed on the device. And the time system service is also being tracked and is currently enabled, loaded, and active. On the terminal, let's try a few commands to re-examine the device. The message of the day is added. The drone cam container application is running on the device as well, and the drone cam image is present on the device. Perfect. It looks like the device has reconciled to the desired state defined by the fleet configuration, including system configuration and application deployment, with the only manual step in this demo was to update the device label. Let's see if our drone cam application is running perfectly. Great job. So we have successfully stood up the new Edge device and our virtual pizza delivery is on its way, somewhere in the Greek islands by the look of it. Now that this device is onboarded and enforcing fleet-defined state, we'll use it to explore a few additional Edge Manager concepts. We briefly looked at device system status and resource status earlier. Let's configure a system disk resource monitor and apply it to our fleet. To do so, we'll use the flight control CLI. We'll export the drone fleet configuration to a YAML file and then update. Observe the spec section. Note that this fleet specification now defines an application, which is the drone cam app, a host configuration source, which is the update MOTD, and the system D service that must be present and running. Together, these entries define the desired state of that the Edge Manager continuously enforces for every device that matches the fleet. Let's add a custom resource in the device spec. This specifies a trigger warning alert if the disk usage on system root exceeds 5% for longer than 1 minute, and a critical alert when it exceeds 90% for more than 10 minutes. Let's apply the update and we'll see the device status change to degraded and the disk pressure is now reporting past threshold. Under the covers, Edge Manager uses Alert Manager to evaluate resource monitors and generate alerts. These alerts can optionally be forwarded to external monitoring systems or SNMP trap destinations if desired. Let's explore events to see how Edge Manager records and surfaces this condition. This overview UI aggregates health and status signals across all managed devices and fleets. The device status bubble is indicating 100% degraded because we have only one device and that device is currently degraded. The Edge Manager UI that we have been utilizing gets its content via the Edge Manager API service. We can utilize the CLI to retrieve the same information. Let's get the name of the device and look at the status by inspecting device YAML. We can also verify through the device console. We can also issue remote commands without opening an interactive device console session. This completes the final section of this demo. I hope you found this helpful. From a technology perspective, we saw how Edge Manager combines image-based OS management, GitOps workflows, fleet abstractions, and application lifecycle management into a single control plane that detects and remediates configuration drifts throughout the continuous desired state enforcement. From a business perspective, this approach reduces operational risk, minimizes manual interventions, and enables consistent, policy-driven operations across distributed edge devices. Thank you and have a great day.